Hi there, my name is Mark and this is Pacific Northwest Solar. Our family has a solar array installed at our property in rural western Washington state, on the west coast of the United States. I've been inspired by other YouTubers to share my experience with our solar array and how it impacts my power costs. This video contains highlights from 2024 that I wanted to share with you. Please also see the link to my separate video that gives more details on our installation, listed below in the description. As a reminder, here's a picture of our 16 kilowatt ground mount solar array. The solar array is directly south facing in one of our pastures with no trees or other obstructions around it. We have 50 sunshine panels, rated for 320 watts each, with Hoymiles M300 microinverters on the backs of the panels. These microinverters convert the panel's DC output to 240 volt AC power, which is sent back to the breaker panel at the house. There is only one choice of electricity providers where we live. Currently, the cost of electricity from the grid is the same no matter what day or time it's consumed, no time of use rates. Any power generated automatically goes to usage in the house first, and then any additional is automatically returned to the grid. We get a 1-to-1 credit for each kilowatt hour that we send back to the grid. These credits directly deduct from the power we are charged at the end of the month. As you can imagine, the overall idea is to overproduce in the summer and use the credits to reduce or eliminate the electricity bill in late fall and winter months. I am using a Sense device in my electric panel to track power generated and power consumed, and I have written a custom Python program to capture real-time metrics for the entire system that I save and analyze. Here is what the Sense app shows for the entirety of 2024. Overall, solar production was 18.46 megawatt hours, overall usage for the year was 17.63 megawatt hours, total energy to the grid was 12.54 megawatt hours, and total energy from the grid was 11.70 megawatt hours. The peak of solar production, at my latitude with my angle of the solar panels, is in July. Looking back at 2023 and 2022, that is also consistent. The net number is very interesting, as it shows that we produced more electricity than was used over the course of the year. Of course, the production and usage is different at different times of the year, but it makes you wonder if being completely off-grid is feasible. The two grid from grid numbers also support this possibility for consideration. More details to come in the following slides. Here is a comparison graph for the maximum amount of kilowatt hours of solar production in a day, by month, for 2022 through 2024. This value was higher in 2024 than it was for 2022 and 23 in most cases and represents the best production that I can have, subject to the specific weather conditions. Here is a comparison graph for the average amount of kilowatt hours of solar production in a day, by month, for 2022 through 2024. This value was higher in 2024 than it was for 2022 and 23 in some cases. The low average in June of 2023 was when the solar array was offline for 3 weeks. It's easy to see how much variance there is between winter and summer months, over a factor of 4. Here is a comparison graph for the minimum amount of kilowatt hours of solar production in a day, by month, for 2022 through 2024. The zero value for November 2024 was due to a grid power failure for part of several days of the month, and my system cannot export solar if the grid is not present. The zero values in June/July of 2023 were due to the solar array being down for 3 weeks across June and July. Here are the highest identified users of electricity for the year. It's probably not surprising that heating hot water used the most energy usage of anything in the house at over 2.1 megawatt hours. In fact, we have 2 different electric water heaters, and if both happen to be on at the same time, the Sense device doesn't properly pick that up and record the energy usage correctly. The hot water that is used for cooking, dishwasher, and laundry is the one listed here. Even though it's located in the unheated garage, I have entombed it in R15 insulation and insulated both the cold and hot water pipes to minimize the heat loss. The next highest energy user is our electric furnace. We don't have natural gas in our rural area, but propane is available at our house. It uses 15 kW when it turns on, with its electric resistive heating elements. It was less than 2 years old when we moved in, so it didn't really make sense to replace it at that time. But you could argue that putting in a high-efficiency heat pump would have solved both the heating and cooling needs with one system. The power usage of the electric furnace is so high that the Sense device doesn't properly measure it at times. Note that the graph says the electric furnace wasn't used in November or December, and that certainly was not true. The final single highest energy user was the air conditioning outside compressor. The AC connects into the furnace system as is typical and runs on the same thermostat. With a usage of just over 1 megawatt-hour of electricity, it comes out to about 5% of overall usage for the year for this one appliance. Here are a couple other interesting devices that had significant energy usage for 2024. Our well pump is extremely important to us, so we can have fresh water. Normally, the well pump will run between 3 and 4 minutes each time it detects low water pressure in the water pipes. Its power consumption is right about 1 kW. You can see the highest water usage is in July, when we do the most watering of grass and our garden. The electric clothes dryer also uses a significant amount of energy over the course of the year. Overall usage was down at the end of the year as compared to the beginning, since we had fewer loads of laundry due to less people in the house. Finally, there is a very popular beverage fridge that hummed along with an average of 87 watts of electricity usage while it was on. I have some thoughts about potential improvements that could be made to either increasing production or reducing usage. There are two cases to consider. 1. Where my power utility continues with the flat power rate for electricity usage for any time of the day or night, and 2. If time of use rates come into effect. Let's consider the first case here. The main goal would be to improve the percentage of being independent of the grid, which is currently at 34% for 2024. I could potentially increase this number by shifting my load usage to the middle hours of the day, when there is the most sunshine. I could also purchase timers for the hot water heaters and have them enabled for midday and overnight times. I think this could help some, but in the winter, there isn't that much sunlight to take advantage of. Let's consider the second case, where my electric utility requires everyone to move to time of use rates. In this case, the goal would be to shift all possible power usage outside of those TOU windows and into the midday, when the solar production is the greatest. I could certainly put the water heaters on timers to not allow them to run in the high-cost hours, and it probably wouldn't be very noticeable. I could also go one step further and spend additional money to get a battery backup system installed, with the goals of using solar to charge them in midday and cover all possible power usage during those TOU hours. Give the typical energy pattern usage at my home. I think I would need at least 30 kilowatt hours of storage, and that coupled with the inverter and other required items would be very expensive. Not sure I'm ready to shell out that kind of money. It's good to know that it's an option though. I wanted to look at some additional details this year from the data I've collected. Specifically, I was wondering what the numbers look like if you look across the entire year, on a per hour of the day basis. This graph shows the total number of kilowatt hours generated, used, sent to the grid, and pulled from the grid, with each hour from 9 a.m. through 9 p.m. There are several interesting things shown here. First, the peak of solar generation for my system happens from 1 p.m. through 5 p.m. Since solar noon in the Seattle area is around 12:30 p.m., this must mean that the angle of my solar panels is skewing the peak solar generation to later in the day. Interesting. Second, the overall amount of power used per month doesn't fluctuate as much across the year as I had thought. It looks like only about a 40% difference between the highest and lowest months. Thanks for watching this full year review of my solar system's performance. Please give this video a thumbs up so other people will be able to view this video. If you have any other statistics that you would like to see, please leave a comment down below. Have a great solar day and see you next month.